This is the first in a series of videos on probability. And in this video, we focus a lot on the terminology that we use in probability. So the first thing is that probability is based around the idea of a random experiment or an experiment. And first, let's talk about what we mean when we say experiment. This is not necessarily the experiment that you talk about in science. An experiment in probability is just simply an action whose outcome is based partly in chance. So let's just say an action with the result based partly on chance. And I want to focus here on the idea of partly. So an experiment could be something that is pretty well known, but not completely known, right? Or it could be something that's completely random. We'll use the term chance and random interchangeably in the beginning of these videos. Now, a big part of the idea of probability is we differentiate between what we call an outcome and an event. And this is, in some sense, an artificial distinction that makes the math much, much easier. So we say as an outcome, an outcome is the result of an event. But it's a special kind of result. It's a result that is irreducible. And the way to think about it is, by analogy, it's sort of like an atom. Or at least the way that they used to think atoms were. It was the smallest building block. It's the smallest result of of an experiment. Whereas an event is defined as one or more outcomes. So when you have an experiment, you have a series of outcomes, and those outcomes can be grouped into events. For events, we have what's called a single event. A single event is simply an event with one outcome. And a compound event we define as more than one outcome. I think this will be clear when we look at an example. If we look at an example, let's roll a single die. And then if you think about a single die, that's partly based on chance, clearly, because you roll and you're not sure what you're going to get. And if you think about what are the outcomes, let's list the outcomes. Well, the possible outcomes here are you could get a 1, you could roll a 2, you could roll a 3, you could roll a 4, you could roll a 5, or you could roll a 6. And in some sense, you can't reduce the 2 anymore. If you roll a single die and you get a 2, there's no way you can subdivide that outcome. So these are the smallest possible results. Where an event might be an aggregation here. So let's say one possible event, let's call it 8A, is that you roll an even number. So if you think about rolling an even number, that has a couple of different outcomes in that event. You could roll a 2, a 4, or 6. Another event is that you could roll a number less than 3. If you roll a number less than 3, then that means you either roll a 1 or a 2. And the last example of an event is, let's say you roll a number greater than 5. And if you think about all the numbers greater than 5, that's a 6. So if you notice, this is an event, but it's also an outcome. So this is called a simple event. And these are called compound events. The last terminology we want to really focus on is the idea of a sample space. A sample space is a listing of all possible outcomes. And defining the sample space is very important because from that we can derive our probabilities. So if you think about the first experiment, which was roll a single die, then the outcomes, we often write it like this. We give the experiment a letter and we use this curly bracket. There's no reason we have to, but that's typically the way we do it. And 1, 2, 3, 4, 5, 6. Let's think of a more complicated example. Let's say the experiment was the weather tomorrow. Now, that's going to be pretty difficult, actually, because if we're going to think about the weather tomorrow, to list that out, we would have to list out every possible outcome. So one possible outcome is it's sunny without rain. Another one is it's sunny with rain. Another one is maybe that it sprinkles and it's cloudy. And what you notice here is that this almost goes on forever, right? So to literally live the sample space sometimes is almost impossible, right? Because even though it's not likely tomorrow, it could be sunny and hail tomorrow. And if that's possible, you have to include it in the sample space. So that's the idea of a sample space. Sometimes they're not so hard. The last step that I'd like to do is I'd like to review some rules about cards. Because when we look at cards, a lot of our probability was derived from card games, and it's a really nice example. It's fine if you don't know cards, just write down the rules and memorize them. A basic deck of cards has 52 cards. Sometimes there's 2 jokers, but this is unusual, and we're going to assume that there's not jokers. So generally there's 52 cards without jokers. And what you have is you have what are called suits and ranks. And if you think about suits, there's 4 different suits. You have hearts, you have diamonds, you have clubs, and you have spades. And I'll just draw them, or at least I'll try to draw them. This is how I draw a heart, a diamond, a club, and a spade. Spade is just a shovel. All right? Then, in addition to the suits, for each one of the suits, you have what are called ranks. Now, most people don't know that they're called ranks, but they know what they are. And the ranks, they start at 2, 3, 4, and they go all the way to 10. And then there's a jack, and then there's a queen, and then there's a king, and there's an ace. And the jack, queen, king, and ace are called face cards. And they're called face cards because they have faces. The ace is sometimes considered the highest card and sometimes the lowest card, or sometimes both, usually the highest card. And you have, so what you do is for each one of the suits, you have 13 ranks. So there's 13 ranks and there's 4 suits. And what's neat about this is that you have overlapping. So for example, if you think about all the hearts, there's 13 hearts. And then there's fives. If you think about fives, there are 4 fives. And there's 1 4 of hearts, right? And that's we play with that a lot when we do probability. So make sure you understand this. Just stop and ask me or go buy a deck of cards and make sure you understand this or use this as a notes. So that's the first part of probability. And now you're going to watch video number 2.